In this video, I'm going to talk about data analysis and how we have to consider it in our IGCSE fieldwork. So data analysis is a topic that can come up in terms of your fieldwork, and it essentially means when we have to do something with the data. So transform it, process it, and this helps us to able to see patterns in it, see contrasts. Examples of descriptive statistics that we might use to actually break down data would be taking a mean, median, mode, range, or doing a statistical test. So I'm not going to go through all of those. I'm going to give an example of how we might be able to do it, and then give an example question at the end that you can attempt to do yourself. So it's a really important part of the fieldwork. Data analysis comes after we've collected the data. And often in the exam, they'll ask you an evaluate question. So an 8-marker, well, they'll get you to either evaluate your own data analysis methods, or they'll give you some unfamiliar data and get you to interpret someone else's investigation. When we think of the word evaluate, we have to think of 3 key areas. What are the strengths of the data analysis method that we've been using? What are the weaknesses or the limitations? And we have to weigh them up against the strengths. And then we need to say, is there any way we could have improved the data analysis methods that we took? So I'm going to give an example here of how we might apply this to Rivers fieldwork, and then see what the kind of strengths, weaknesses and improvements are for a couple of examples. So the most obvious thing you could do is take a mean. You might colloquially hear it being called an average. I'm going to use it as an example for velocity. And here I've taken 4 velocity readings in the upper course. This is technically I'd probably use something like an orange, which I'd throw in the water and it would float down, and I'd measure the distance. If I was doing it much better than that, I'd take a flow meter reading. But I've got these scores of 10, 5, 4 and 5. The mean that it's given me when I add them all up and divide them by the number of times I've done it is 6. The strength of this is that by taking an average, I reduce the impact of anomalous results that might skew that data. So it doesn't completely erode the outliers, but it reduces the significance of it. It's very, very simple to calculate. You can do it very quickly, which means that you can get into the analysis much more quickly rather than a complex formula. The most important thing is that you can actually compare it with other parts of the river quite easily, because you get a figure or quantitative data. So I've got a score here of 6. I could take 4 readings in the middle course and take an average, and then take 4 in the lower course, and I could compare how the velocity changed from the upper course to the middle course to the lower course. In terms of weaknesses, because we've got a very small sample size here, it's very sensitive to that. So if we get an extreme value like we have here, 10 is quite extreme in this data set, it can skew it. So even though taking an average does reduce anomalies, extreme values will obviously affect the mean. So to improve using the mean, which we can say, if I was going to write this in a question, I'd say it's a pretty effective way of being able to analyse the data. Our improvements, I would say, I would try and take a larger sample size to reduce the anomalies even further. And then I would get my data, my raw primary data, and compare it with secondary data. This means my data analysis would be much, much better, because I could compare it with a legitimate source that had been taken by someone else, and I could see how accurate they were. So what we're trying to do with our investigation here is to make whatever our analysis is much better, and I think by doing that we would get better results, which means our conclusions would be more valid. Another example we could use is range, which simply means how spread out the data is. Again, what I've done here to take the range, I've taken the highest value of 20 for the width here, and I've taken the lowest in the upper course, which is 1, and I've got a range of 19 meters. So I'm going to use width as an example. It's similar to the mean in that it's very simple to calculate, and it shows us very simply how spread out that data is. So if the data here had actually just been 1 meter, that would show me that there isn't much difference between the upper and lower course. The smaller number means the smaller spread, the larger the number, the larger the spread. Here I've got quite a large spread, of the data, which we would expect. So it's been quite good for analysing my data because I expect to see the width change between upper and lower course. And this kind of gives me an indication that there is quite a lot of variability between the highest and the lowest value. It gives me a figure again, which is very, very good because I can compare it either with secondary data, but I could also compare the range with another river. So I could look at the range in width of one river and I could compare it with another river just to see how large the spread of the data was for either river. In terms of weaknesses, anomalies are very easily can easily impact the range. This makes the reducing the accuracy and therefore analysis is more tricky. So if there, for example, was a width of 100 because someone had measured it badly, that would mean the range would be a lot higher, which obviously affect my overall result, and then my analysis wouldn't be that good. It only looks at the highest and lowest values, so it doesn't look at the width throughout the whole river. Therefore, we can say that because it's not looking at all of the data, so the mean looks at all of the data, the range only looks at the top and the bottom, therefore we can say it's not that representative of changes throughout the whole river. So if I was going to improve using the range, I was still going to use it, but I wanted to use it for my river fieldwork in a better way, I would probably calculate a range for a smaller section. So I would take multiple readings in the upper course, so maybe 5 readings in the upper course for the width of each 5 different sites, and then I would see the range in the upper course. I'd take 5 in the middle course and then see the range in the middle, and then take 5 in the lower and see the range difference there. It would just give me a slightly more representative to see how big a difference there was in the width of the river in the upper course and the middle course and the lower course. It would essentially allow me to analyse different stretches of the river and see any patterns much better than trying to do the whole river. So the one major way that I could improve an investigation if I'm taking raw data is to do a Spearmans Rank. Spearmans Rank is essentially a test that we do with the data to see if there is a relationship between two variables. So this is good because I could get width and depth, and I could, rather than just look at one set of measurements in isolation, I could see if there's any relationship or pattern between the two. I've chosen width and depth here because I think that there should be a relationship if I had a hypothesis with saying as width goes up, depth should go up. It also gives me a chance, if I do a Spearmans Rank, it gives me an actual figure which can tell me if it's statistically significant or not. For IGCSE, you don't actually have to be able to work out a figure or even give the figure in the exam, but you could argue that you've done it, and then you could say it was statistically significant, and you could talk about the relationship between the two bits of data. So here I've used the scatter graph to actually present some data, which is a very, very good way of presenting two variables. And I can see that as the width goes up, the depth goes up. So we can say that this would be, if I put this into a Spearmans Rank, therefore there would be a positive correlation. As one of the variables increases, the other increases. By looking at both of these sets of data together, my data analysis is much, much more complex. I'm not looking at the measurements in isolation. I'm looking them to see how they relate to each other. So as soon as I start to do that, that is a really, really good way to improve my overall investigation. So an example question you might get would be, if it was for your own fieldwork, it would say, evaluate how successful your chosen data analysis methods were in answering your question. You then have to put your question. For example, you might have had a question which says that you made up with your teacher saying how the characteristics change from source to mouth on the river, whatever you studied. Or you could have had something as simple as a study of changes in the velocity, width and depth on the river, blah. What I'd like you to do now is have a go and see how you would answer that question using what you've done in the video. And in a second, I will show you what the first paragraph would look like. I'm not going to show you the whole answer, and you can see how well you've done. The first paragraph I'm taking on is about the mean. So I'm going to put my first answer up here. I'd pause the video here and read the answer. It shows you not only what is good about the mean. In this one, I actually didn't talk much about the weaknesses. I just talked about how successful it was, and then I talked about improvements. You can do that. This would get you enough credit to say it's pretty successful, because you're making a judgment to say, I think it's more successful than unsuccessful. But then because you've given improvements, you're saying it could be even better. So you're still saying it has kind of some weaknesses in it, or ways that you can improve it. This is a kind of answer that I would start to write for my first paragraph, and then I would go on to probably something about range and using a stats test in my second paragraph.